Good day, everybody. I want to start out by writing down an algebraic identity, and this isn't particularly well motivated initially, I don't think. And I do want to point out one little truth here that I think a lot of you have already observed. One way to do this would be just to find a common denominator. You'll note that 41 squared is 1681, and you could find a common denominator, but you would end up with a fairly large fraction or integer in the numerator, right? 41 times 97, you have to add that to 784 and put that sum over 1681. And this is a standard no calculator type of question, and so that's a possibility, and it's definitely a way to do it. But I'm gonna try to leverage an algebraic identity here. This very well-known result. And it's natural to consider an object squared since the square root of an object squared is the object. But we have 2 squared. By the way, congratulations to Alexander Ayala for her tremendous upsurge. Philippine female tennis player has beaten a very strong player twice in a row. I think the young lady that won the Australian Open. But anyway, congrats to her for her excellent performance. Now, this looks pretty strange, right? In other words, why in the world do we do this? 2n is equal to n plus n, sure. But what does that have to do with this problem? Well, let's take a look and see exactly what it does have to do with this problem. Now, if you'll take a look right here at this particular piece that I've done for you, I split it apart. Why did I split it into 28? Because 28 squared is 784 is equal to 784, and of course 41 squared is equal to 1681. I won't write that down. 28 squared is 784, not quite as easy to compute. 41 squared is pretty clearly seen to be 1681 without using a calculator. All right, but notice that what we get right here is we actually get, you can think of this, and I'll write it directly underneath here. That would be your n squared. This first one would be n, and what's kind of hard to pick up is this second one is n plus 1. The second one is n plus 1. Again, y'all, that's not too hard to see, right? 41 and 28 is 69. So here's n squared. This part right here is n squared. This part is n. And this piece right here is n plus 1. Now, that's kind of hard to pick up, and it's hard to know to do this. But there's hardly any computation here outside of knowing that 28 squared is 784 and 41 squared is 1681. Up here, you would have a larger computation, okay? So what we're getting right here is that, let me just come, based on this result right here, again, you can see n squared, n, and n plus 1, which is exactly what we have here, which is equal to a perfect square, okay? So in other words, what we're going to get right here is this piece right here is your n plus 1, and so you're going to have that this is equal to the square root of 69 over 41. And y'all, this is a standard problem I have. I need to do something. I keep saying it, but I'm never going to do it. But this last term, quantity squared, that's kind of neat how it manifests based on this identity right here, okay? All right, so we have n plus 1 quantity squared is equal to all of this, and so we have n plus 1 right here, okay? So we have 69 over 41, okay? But, and then, so there you go. That's what it's all equal to, okay? This whole object right here is equal to this. But then this is equal to, what, I lost my marker. This would be equal to 69 over 41. And again, apologies for not, I probably will keep saying that till I croak. But the answer to the question is 69 over 41, and it follows very quickly once you know to split. Now, I admit this part's sort of unmotivated, but I didn't want to do any big computations. I wanted to make it depend on an algebraic identity. So anyway, that gets it done, folks, and thank you for viewing.